Sam from Developing Mathematical Thinking, and today in this video, we're going to look at addressing some different misconceptions that students often have about the area model for multiplication. So one of the major parts of the DMT framework is addressing misconceptions directly and trying to help kids make sense of why the things they think might be correct aren't really applying the way they want to. So the first thing I want to draw your attention to is this version of what kids typically call the area model. Sometimes they call it a box method. And if you just think about how you've decomposed 12 times 13, that's going to be our target problem we're working on. You've got the 12 here decomposed into 10 and 2, the 13 here decomposed into 10 and 3, and each of these sections is representing the partial product. So saying like 10 times 10 is 100, 10 times 3 is 30, 2 times 10 is 20, 2 times 3 is 6. So there's those 4 different sections when you decompose this particular problem by place value. Now, there's an issue with this method when you're dealing with numbers specifically, and that is that it's not accurate in terms of the relative sizes, the proportions between these different sections. And so if you were to actually map out on graph paper a 12 by 13 array, an area, it would look a lot more like this model that I've sketched out. The 10 by 10 section would be a square, and then, for example, the 3 by 10 would be just a little bit larger than the 2 by 10, but they'd still be pretty close to the same size. And then that 2 by 3, that section here, that would end up being quite a bit smaller. That's a much more accurate representation, and it helps build kids' number sense. And it also, again, connects to what you would actually build either iconically visually on graph paper, or if you built it with tiles or place value units. Now I want to show how to help make sense of this particular representation as a good exercise to get kids to understand where these 4 sections come from. So I'm going to move down here to this model for just 12, and it's just a place value model for 12. I've just drawn the 1 unit of 10 and 2 units of 1. And now what we're going to do is, just for a moment, we're going to actually move ahead a little bit to connect to the XY coordinate plane, just because there's kind of a nice connection. And I'll show you how to come back to this one. But what we're actually going to do is take that 12, like it was the x-axis, and we're actually going to iterate, meaning to copy over and over. We're going to iterate these 12s vertically until we get to 13 12s stacked up like this. So what we're basically going to do is iterate. So now there's 2 times 12, and we're just going to keep going until we get 13 iterations of 12. Okay, so we've iterated that 12 decomposed by place value into 10 and 2, and we've iterated it vertically 13 times. Now, again, the reason why I just wanted to iterate it that way was it does match that XY coordinate plane and starts connecting to some algebraic ideas. But before we wrap up, I'll show you how to build this idea in a way that matches up with that arrangement. So if we look at the 13, if we count up until we get to 10, right here, so there's the 10, what we actually have, if we start with just this 10, this section here ends up being that 10 by 10, that 100, and you can see the 10 units of 10. Then if we look over on this side here, you've got a 2 by 10, which is going to be that 20. And then in this section where now we've got the 3, you can see that we end up here with the 10 by 3, which is the 30, and then here the 2 by 3, which is the 6. So these are in a different arrangement than they are here because we went up vertically, but it shows where each of those 4 sections comes from. And if you want to connect from this model to this model, the difference would be you would just start with the 12, and instead of iterating up vertically like the y-axis, you would just go iterating down that direction, and that's where this model would come from. Okay, again, doing this on graph paper can be really, really helpful because it will help keep kids' drawings proportional, and that will help keep their number sense and place value intact. I hope this was helpful. Try this idea out with some graph paper, and hopefully it will help clarify some of these misconceptions and prevent kids from just drawing this method. you.